Hello, welcome back to our lecture. Right, that is chapter 5 in this one, right? Chapter 5, we're doing the statistical reasoning. Right, the first unit is about the fundamental of statistics. Right, there are two definitions of statistics. One is the subject. Right, the statistics is the science of collecting, organizing, and interpreting data. Right, that is the science of object. When we trying to researching on something, right, we usually collecting data, and then organizing data, and then interpreting data. And another type of statistics, right? Two things, right? Another type of statistics is the data we have. Right? Statistics are the data that describe or summarizing some thing, right? Something. So-called sample, right? Describing and summarizing something that is part of the object. Right? The idea is, well, the object we studying is hard to study every single item, right? So we use the subject statistics to do something with it, right? Make it doable, and still the result may be representing the whole object, right? The entire object. And that data we collect is called statistics also, right? So two definition of statistics. Pretty much they're different thing, right? So when you're talking about the general topic, that's called statistics. When you're talking about the data collected, that's also called statistics, right? But different environment will have different meaning, right? Okay. All right, so the definition of population and sample, right? Unlike the usual word population is amount of people, right? In statistics, the population referring to what? In statistics, study is referring to a complete set of people or objects being studied, right? Complete set or people or object, complete set of people or object, right? It is considering as a complete set, right? Where the sample is the subset of the population from which the raw data are actually obtained. Right? Most of the case, the population is huge and impossible, right? Even could be hard, but even impossible to get every single item or person or object being collected, right? Being observed or being surveyed, right? Or collect data from. So what we need is usually study on is the sample, which is the subset of the population. By subset, we just surveyed maybe a couple thousands, couple 100,000 of subject of the, I mean, not objects, right, or items or persons. That will be possibly doing it, at least possible to do. So usually we're focusing on the sample instead of the population or from the population actually. That is the data we're actually obtained is called a sample. And the population parameter are specific characteristics of the population that a statistical study is designed to estimate. Right, so population parameters need to be estimated, and that is the purpose, right? That is the desire of the experiment we're doing or event we're doing, where the sample statistics are numbers of observations that summarize the raw data. right? The data collected from the sample and summarizing it is called sample statistics. Usually will be that a good estimator or good representative of the population parameter. All right, so that's what it is. And here, right, we need to describe the population sample, population parameters, and the sample statistics. Right. So let me highlight it. Agricultural inspector of Jefferson County measures the level of residue from 3 common pesticides, right, on 25 years of corn from each of the 104 corn producing farms in the county. Right, so that's a sentence, right? What they want to do, actually. They want to measure the residue in the county, right? So Jefferson County is right, let me erase that part. That's a mess here. Right. So Jefferson County is the place, level of residue, total whatever in the corn producing farms, right? Want to measure the level of residue in the corn producing farms. Right, so that's the Jefferson County. Want to measure the level of residue in the corn producing farm. Right, so the population that is actually all the corns in the corn producing farm, right? In Jefferson County. Right, so all the corns in corn producing farm in the Jefferson County is what they supposed to test it, right? But it's hard to do, right? As long as they want to find the level of residue, how to do that is from 3 common pesticides, right? But the subjects, right, they cannot do all the, they are not be able to like observe all the corns in that producing farm, right? So in all the producing farms, so what they do, they take out 25 of the corns from each of the 104 farm, right? That's what they do. They're making a smaller reasonable sample, right? So those are those corn actually being tested, right? How many of them? That's what they are, right? So the population here is what? All the corns in the corn producing farm in Jefferson County, right? And the sample we get are those corns which are being tested, right? Those corns which were tested. Right, then population parameter in this case, that is the level of residue. From, of course, the corn producing farm. In the Jefferson County. Right, but that's the level of residue. Right, and that is the purpose, right? But in this question, we have sample statistics. First of all, apparently, I will get the numbers. That is, the size being tested is 25 of each of corns in the 204. That will be 2,600 corns being tested. And also the level of residue. On the ears of corn. Being tested. So population is the every corn. The sample are those corns being tested, right? Population parameter will be level of residue from corn producing farm in Jefferson County. And the size, I mean the sample statistics, first of all, we can see the size. There are 2,600 of the corns. Right? And the statistics we get is level of residue from those 3 common pesticides on the ears of corns being tested. Right, so that's this question. By reading your question, break it reasonably, then break it reasonable, right? Then we can see what we're seeking to find. Right, the next one. Anthropologists want to determine the average brain size of early Neanderthals, right? The early Neanderthals. And what they found. By studying schools found at 3 sites in South Europe. Right, early Neanderthals, nobody knows how many they are, right? That's impossible to know. But what they want to do is they want to find the average brain size of them, right? So the population are actually what? All the early Neanderthals. Right, that's the population. We don't even know how many they are, but all of them are what we are considering, right? We saying, well, oh, their brain size is what, or is kind of averagely like Einstein, right? The size of Einstein, but it's based on just the sample we get from those three sites, right? Those are all the sites, but we are not sure, right? If all of the Neanderthals are left their scores in the sites, right? Or there should be someone who doesn't have the body remaining, right? All the way to now. That's impossible, right? Those we have the sample, right? Those Neanderthals. Found at 3 sites in Southern Europe. Right, it's named by a place of Germany, right? So those Neanderthals were found in a place called Neanderthal in Germany, right? South Europe. So those actually the question provided, right? From those schools found at 3 sites in Neanderthal in the Southern Europe. Right? So those people or those human beings, right, found at 3 sites in Southern Europe. That's only the sample we get, right? Then the population parameter is actually the average brain size of all Neanderthals. Average brain size, that's the population we're looking for, right? But the sample statistics are what, or is what? The school size of those Neanderthals in 3 sites. Right, that is the sample statistics, right? Average school size, or we need to put the average school size, right, to be more accurate. Right, only the school is only the schools are able to represent the the brain size, right? We don't know how large the brain is, but based on the school, we're able to see, right? Then the average school size can be able to show like maybe the population will be able to represent it, right? But that's the only thing we have. Right? All right, then the next one. Harris poll, 2,300 adults in the US were surveyed about body piercing. 5% of them responded said they have body piercing, but not on the face. Right, so that's what the survey is about. Then, right, the latest available at that time, there were That million adults in the United States. So basically the result from the survey are sample drawn from the population of all adults. All right. So they give us a proportion of those who said that has body piercing but not on the face, right? So what they want is to see or the proportion of United States adults who has body piercing but not on the face, right? So the population will be all adults in the United States, right? And the sample will be just those adults who were surveyed. Right, those people who were surveyed are our only sample. Right, then the population parameter. First of all, we have the size that is 2,241,472,385. Right, this is the size of the population. Well, here population and the population in the US, well, similar that they have different thing, but actually turns out to be same meaning, right? The population size and the population on the size of the population, right? And how many people in the population. Anyway, have the size. Also, they want what? The proportion of people right? Proportion is one kind of data. It will leads to the how many of the person, right? But the surveyed, like the paragraph or the written or the sentence or the conclusion is written based on the proportion, right? So we can assume, well, there's only proportion here, right? So another thing is the proportion of US adults has body piercing. Not on the face. That is what's surveyed for, right? Do you have a body piercing? That is not on the face, right? That are the population parameter, even though the proportion of the population is unknown, right? But that is what we looking for, or that is what the sentence trying to get conclude. So that is the population parameters they want to get. And the sample statistics, first of all, the size, which is those adults who were surveyed, right? That size is 2,320, and the proportion is 5%. Who has or who had body piercing. That's not on face. Well, maybe I could write a little better. Right, not on the face. Okay, so that is the sample statistic, right? Those 5% is the sample proportion. The proportion 5% is who has body piercing not on the face, right, from the sample. Okay. Right, so that is to distinguish population, sample, parameters, and statistics. Right. Then types of collecting data, right? We have before the statistics is a subject or is a science, right? That's test, collect, observe, or interpreting. Right? And the types of different way to collecting data, we have random sampling, which each member of the population has equal chance being selected. Right? That's random sampling. Simple random sampling, which is the most widely used, the most random sampling we can find, is what a sample of n objects is selected in such a way that every possible sample of size n has the same chance being chosen. Right, so we want to select size n. So there will be groups of size n being separated first, right? Group of size n, but those has some amount of different group, then we just choose one from all those groups, right? All those possible groups. Of course, one person or one object can be appeared in many different groups, right? That's thing you will see in the later chapter. But that is group sampling, right? Simple random sample. And that is what leads to the most accurate result, right? The result from group, from those simple random sample will leads to most accurate result, right? That result can be best represent of the population, right? So that will be the most commonly used one. Systematic sampling, the next one is select some starting point, then select every case element in the population. Right, so for a population, maybe go like arranging it from 1 to whatever, right? 1 to the end. Then starting maybe from the 10th, then select every 20, right? Every 20th. Just skip to that or the object being selected, right? That's systematic sampling. Convenient sampling, just well, it's apparent, right? Apparently very clear what it is. Just maybe if I want to do a survey of about all the students at BMCC, right? Maybe I can just go to you guys, right? Maybe I can just go to one class and give a flyer, right? Ask you to fill out the survey, right? Something like that, right? And the class being selected is actually just a convenient sampling. Right? I don't want to do anything else, but just convenient enough, right? Of course, some other noises, right, need to be considered and not including, right? The next one, stratified sampling. Subdivide the population into subgroups, then draw the sample from each subgroup, like what we see before, right? Here, we have 104 subgroups of the farm, right? 104 corn-producing farms in the county. Then each of the farm just take out 25 corns, right? That is actually the stratified sampling. Just make the subgroup. That question was naturally subgroup, then draw the sample from each subgroup. Right, and the cluster sampling is a little different than the stratify, even though that's also dividing, right? Dividing into subgroups. But here is divide the population into clusters. Then randomly select some of those clusters. Chosen all the numbers from those selected cluster. So when it's done cluster sampling, right? Maybe that's done in this question, right? By one of 104 different corn producing farm, maybe it takes out 1 or 2 or 3 or 4 different farms and testing on every corn in that farm. Right, so that will be cluster. Right. So that's all about the fundamental of statistics. Right, that's all about the fundamental. So thank you.